In this final video for lesson 2 on applying properties of rational exponents, we're going to simplify some expressions that have radicals in the denominator. So first of all, I'm going to remind you how to do that. In order to rationalize the denominator, we'll go back to an easy one we learned a few months ago. If I have 2 divided by the square root of 3, I'm not allowed to have a radical in the denominator. So what I'm going to do is I'm going to rationalize the denominator. I'm going to turn the denominator into a rational number. Oftentimes it means just multiplying it by itself. In this case, the square root of 3 times the square root of 3. What I've done is I've created a perfect square. And oftentimes we don't write this step, but this is really what I've done. The square root of 3 times itself becomes the square root of 9. And the square root of 9 is 3, a nice rational number. Now, if I do something to the denominator, I need to do the same to the numerator. So we end up with 2 times the square root of 3. All over 3. This 3 is in a radical. This 3 is not. I can't combine them. 2/3 is not reducible. So this would be the simplified expression that I was looking for. Keeping that same idea in mind, now we're going to simplify a radical expression that's got a 4th root in the denominator. So what I need to do is I need to rationalize the denominator. The trick is, if I multiply this by the 4th root of 3, which is itself, I'd end up with the 4th root of 9. I'll write it down here because we're not actually going to use it. The 4th root of 9. Well, would that do me any good? No, because 9 is not a perfect 4th power. It would still be this radical expression, which is no good to me. So what I need to do is I need to think about how do I create a perfect 4th power. Well, a perfect 4th power would be 4 factors multiplied together. In this case, a perfect 4th power would look something like this. 3 times 3 times 3 times 3. Or 3 to the 4th. If I had the 4th root of 3 to the 4th, I'd have a nice rational number. So that's what my goal here is, to create a perfect 4th power. To do that, I'm going to multiply by the 4th root of not just 3, but 3 times 3 times 3. I already have one 3 in a radical. By putting 3 more 3's underneath that 4th root radical, that would give me the 4th root of 3 to the 4th power. And if I've got the 4th root of 3 to the 4th power, which is, if you multiply all these 3's together, you get 81. Well, that's a perfect 4th power, and would thus become the 4th root of 81, or the 4th root of 3 to the 4th is 3, a nice rational number. Now what I need to do is I need to multiply the top and the bottom by the same thing. So what I'm going to do is I'm going to multiply the numerator by the same expression, except the only difference is I'm not going to write out all 3 3's. I'm going to just take 3 times 3 times 3 and write this as 27. So that's really what I'm multiplying by, is the 4th root of 27. Because there's 2 terms in the numerator, really what I need to do is then I need to distribute that expression. So I'm going to take negative 3 times this, so I'll have negative 3 times the 4th root of 27 plus the 4th root of 27 times the 4th root of 6. Now this is going to be interesting because these are both 4th roots. So what I can do is I can take the 4th root of 6 times 27. Now I would have to simplify that expression if necessary, and I think I'm going to need to do that. So check this out. 6 is the same thing as 2 times 3. So 6 is 2 times 3. And 27, if you remember, is 3 times 3 times 3. So if I write all that out, all of a sudden you'll notice that I've got 4 3's in my radicand. These 4 3, well, the 4th root of 3 to the 4th is again going to be 3. So I can actually take out a 3 from that expression like we did earlier, which leaves me with the 4th root of 2, because that's the leftover factor. So I've got negative 3 times the 4th root of 27 plus 3 times the 4th root of 2. And these now, I can't add them together because they're not like radicals, and there's no way that I can make them like radicals. So this will be my numerator, all over 3. So my final answer will look like this. Negative 3 times the 4th root of 27 plus 3 times the 4th root of 2 all over 3, but now what I notice as I write that out, because I'm dividing both of these terms by 3, and they both have 3 on the outside, I can actually cancel some 3's here. 3 divided by 3 is 1, 3 divided by 3 is 1, so we're going to have the opposite of the 4th root of 27 plus the fourth root of 2, and that will be my final answer.